and so on, M, N, A, N. This is the equation, mass of the body into acceleration of centre mass, total mass. Means centre mass is moving with an acceleration as if the total mass of this system is concentrated in it and moving with this acceleration value. Here, according to Newton's second law, M1A1 is force acting on the first particle. Force acting on the second particle is M2A2 according to Newton's second law. Net force acting on the first particle, net force acting on the second particle, net force acting on the third particle, and so on, net force acting on the nth particle. So, resultant of all forces which are acting on the particles of the system makes it centre of mass to accelerate as if all these forces are acting at the centre of mass where the total mass of the system is supposed to be concentrated, that is capital M. Now, what is F1? F1 is net force acting on the first particle. Consider a system of particles. There are many particles of the system. Consider a particle 1, let it be 2, 3, some 4, 5. Then first particle, what is the force experienced by a first particle? First particle experiences force due to second particle, attractive force which is towards it. I call this as F12. Force on the first particle due to second particle of the system. Force on the first particle due to third particle of the system. Force on the first particle due to fourth particle of the system. And force on the first particle due to fifth particle. Like that, all the particles of the system exert force on the first particle. In addition to that, the particles which are lying outside the system can also exert forces, will also exert force on this. So, like that, the net force acting on the first particle is sum of all these forces. Among them, forces arising due to particles internal to the system and particle external to the system. Therefore, we can write F1 as F12 plus F13 and F14 and so on, F1n. This is F1 is all the force which are experienced by the first particle due to the remaining particles of the system. This, in addition to this, the first particle will experience force due to external agent. I call that as all external particles exert a force here. So, these are called internal forces because forces which are acting on the first particle due to the remaining particles of the system. Therefore, this is an internal force and this is net external force, all these particles which are outside the system which are exerting here. Similarly, this I can write it as, similarly I can write for the second particle. Net force acting on the second particle, this also will experience force due to first particle, due to third particle, due to fourth particle and so on, plus this also may experience force due to external particles, external agents. Therefore, this also we can write all the external to the system, whatever the forces which are exerting, we call them as net force external is F2 external. Now, these are the forces. Like that, F3, F4 we can write, and what we notice is when we add up F1 and F2 net forces, we find that adding up of F12 plus F21. F12 is the force on the first particle due to second particle and F21 is force on the second particle due to first particle. These are action reaction forces. When we add up M1, F1 and F2 in this expression, these forces F12 will be equal and opposite to F21, summation of these two becomes 0. F13 is F13, F31 summation will be 0. Similarly, F23, F32 summation will be 0. Thereby, when we consider the summation of all these forces, the internal forces which are in the bracket here will be action reaction forces cancelled out for all the particles of the system together, and the net force now becomes only external force acting on this. Therefore, we can write the equation as F1 is F1 external, net external force acting on the first particle, F2 external, net external force acting on the second particle, and so on, Fn external. So, all these forces which are acting on the particles of the system arise only external, internal forces which are action reaction forces, and the summation they cancel out. Therefore, we can write this as net external force acting on the system is m into ACM. So, therefore, this we can write it as the equation of motion of center of mass. It is Newton's second law applied to the system of particles, and from this we can calculate the acceleration of the center of mass. Center of mass will be accelerating as if the total mass is concentrated at it, which is the mass of the system m, and the net resultant of external forces which are acting on the system are said to be acting on the particle. So, internal forces, though they act on the individual particles, cause the acceleration for the individual particles of the system, but cannot accelerate the center of mass. Center of mass is accelerated only by external forces. Internal forces do not cause any acceleration for the center of mass. That is the conclusion. It is Newton's second law applied to system of particles, and this is also equal to dp Cm by dt, which is also equal to dp total linear momentum, rate of change of total linear momentum, or rate of change of linear momentum of center of mass is equal to F external is equal to m into ACM. This is the equation of motion for center of mass. Now, we will try to calculate the acceleration of center of mass in simple case. For example, in Atwood's machine, how we calculate the center of mass of the system. Let a particle of block of mass m1, another block of mass m2, connected together by an inextensible light string passing over a pulley. Two ends of the string are connected to these two blocks, and pulley is assumed to be small, smooth, and light pulley. Therefore, pulley mass is negligible. In this case, the blocks will be accelerating, and how to calculate the acceleration of center of mass. And in this case, external force is gravitational force as well as force exerted on the pulley by the support, that is ceiling. And pulley, strings and blocks, they form the system, that is this as the system when we consider external force or earth, gravitational pull, that is earth is the external agent. Similarly, ceiling is the external agent, both are exerting forces. Therefore, center of mass will be accelerating, and we have to calculate the acceleration of center of mass. For that, the procedure is, if A1 is the acceleration of the first particle, then m1a1 plus m2a2 divided by m1 plus m2 is m into ACM is the acceleration of center of mass. Acceleration of center of mass is ACM. Now, here we have to calculate A1, A2. For that, write the free body diagram of M1, M1G, and tension. Let the acceleration of this be A upward, because inextensible string they are connected by. Both will have same magnitude of acceleration, whereas this will be moving down, this will be moving up. Therefore, free body diagram of second block M2G, and tension will be this side. Acceleration is towards downwards, assuming M2 greater than M1. Here we are assuming M2 greater than M1. Therefore, it will be moving down, this will be moving up. Solving these two equations, that is equation of motion of this is M2G minus T is equal to M2A, equation of motion of the block. Left block equation of motion of mass M1 is T minus M1G is equal to M1A. Solving these two equations, we get A is equal to M2 minus M1 by M2 plus M1 into G. Now this is the magnitude of acceleration of this downwards and this up.